In Australia, we tend to see a lot of these.
Bushfires. Yeah, we're one of the most fire-prone countries in the world, seeing around 45 to 60,000 bushfires every year.
But have you ever wondered how or why bushfires start in the first place? Let's find out.
Perhaps a good place to start is to understand what fire is. To exist, this wavy hot thing actually relies on 3 ingredients: heat, oxygen, and fuel. What's fuel? Well, it's basically anything that burns. And when these 3 things combine, it causes a special type of chemical reaction called combustion.
This reaction usually releases heat and light, which is the flame thing.
And because heat is both an ingredient and a product, fire is a self-sustaining chain reaction that continues until it runs out of fuel or oxygen.
So basically, a fire needs a spark. But how does that happen somewhere like here? Whoa!
There's many factors for how bushfires start. It can be deliberate arson. A lot of it's carelessness. The other big cause of bushfires in Australia is dry lightning strikes. Honestly, I would say the majority of fires are because of humans.
And because our continent is so hot and dry and prone to drought, meaning there's not a lot of moisture in the environment, it makes it a lot easier for fuel to ignite and burn.
We have a lot of bushfires in Australia because the landscape's evolved with fire. We tend to have relatively wet winters. And then during the summer months, as things dry out, you've got vegetation that becomes flammable and ready to burn.
So how does a fire spread? Well, a lot of it has to do with the vegetation, the weather, and the shape of the land. Hey Robbie, how you going?
But to understand this better, I caught up with Robbie, who's a rural firefighting training officer.
So what do we have here?
Okay, Justina, this is a burn table. We use it to teach our students a bit about fire behaviour. So say a lightning strike, there's no wind here in the situation, so the fire's just going to burn out in a sort of circular pattern. Now the other thing that can affect fire, the 2 main things, is the wind or slope. So what I can do here is light another fire on a 20-degree slope. We see this is where we lit the fire, and we see how we've actually got about 3 or 4 times more distance on this side than the backing or the flank fires.
So can you explain why fire travels faster up a slope?
Oh, certainly, that's a good question. When you have a fire being upslope, the heat coming off the fire actually pushes through the fuel in front of the fire, and therefore that can accelerate the fire up that direction.
The shape of a fire and how many there are can also influence how a fire might behave.
The flames are pretty high.
Absolutely. So that's where we're saying, because it's a line of fire for one thing, and the slope means that the fire behaviour, the intensity is going to be quite large. So you can see the lengthening through there, that's all the preheating happening we talked about before.
Yeah.
And so that just accelerates the fire up.
Why do the flames react that way in leaning into each other?
It's called junction zoning. Basically what happens is the convection pulls together. So instead of 2 separate convection columns, we have them both joined together so that doubles the and there goes our fire.
I'm glad it's only that size.
Yeah.
Yeah, luckily this fire was in a controlled environment. But if a fire was somewhere like here, and we added a bit of wind, well, it would be a different story. You see, strong winds are another big reason to how bushfires spread. Because by providing more oxygen, it increases the intensity. And a change of wind direction can make the fire a lot bigger really quickly.
Yeah, spot fires galore down here. We're talking about 60, 70 metre flame heights. 60, 70 metre flame height.
In some cases, bushfires can get so big and generate so much power, they can even create their own weather.
What the fire's doing is it's producing enough energy in an unstable atmosphere that the fire's convection column or the smoke plume grows vertically, and then the fire can actually generate a fire thunderstorm cloud over the top of it. And in the extreme events, of course, we can see these fire-generated thunderstorms or pyrocumulonimbus clouds can actually ignite new fires downwind.
Another fire spreader are embers, which are burning materials like leaves, twigs and bark, and can start spot fires kilometres away. Not to mention the radiant heat that comes from a bushfire. It can be so intense that the fuel around it can self-ignite.
If they're particularly dry and fine fuels, they will start to burn themselves. So that is one of the ways the fire accelerates. Is also what makes it so dangerous for us and for animals.
So with all this in mind, how do we manage or prevent bushfires?
Well, one way is to quite literally fight fire with fire. We see this with prescribed burns, which involve strategically setting plant fires to reduce the amount of fuel in the landscape, something that's been practiced in Australia for tens of thousands of years.
Cultural burning, it's the First Nations, Aboriginal people, Indigenous peoples' way of burning the country. We call it cultural because it's a part of the culture of the land and the people's relationship. Culturally, we try and keep the fire intensity quite low because we want to protect the canopy. If we do our burning early in the cooler times, when the lightning strike, the fire won't be so bad because we've done all that good fire, all that cultural fire around the landscape.
You see, unlike hot fire, which can kill plants and cause thick, hazardous regrowth, cool fire gently removes fine fuels at lower temperatures, propagates fire-dependent plant species, and allows animals to safely move away from the heat.
So there's a lot of work that's happening across Australia at the moment in Indigenous fire regimes and trying to say how can we actually put good fire, low intensity fire, back into the landscape and make sure that we're nurturing the landscape instead of letting the fuel loads accumulate.
There are a lot of things that we can do too, like keeping fuel loads low around the house, avoid doing activities that could cause an unwanted fire, paying attention to weather conditions, and if you're in a bushfire-prone area, having a bushfire survival plan, so you know exactly what to do if you need to get to a safe place.
This is part of how we live and where we live. We learn about the science so that we can look after things properly, so that we can make good decisions, so that we can provide appropriate warnings and advice to communities for how to keep themselves safe, to make predictions, and that's why it's important we understand the science of bushfires.